So this is my first time, so be gentle with me, please. If it looks like I'm about to die on my arse at any time, please jump in with some questions. It's not pantomime, I know, but that would help me out, you know. So I'm John Taylor. I'm a Scala dev at Cake Solutions. I've been there for just over a year. The notes of the last trips there. We've just been bought, actually, by one of my clients, because all our projects were with this one client, and finally everything bought us. So been bought by a company in New York called MancFUG, but they're currently being mainly bought by Walt Disney. So fairly soon, when that goes through, I'll be working for Walt Disney, I suppose.
Do you get freebies?
That's unclear at this stage. They're a bit vague about all that stuff. So
Are you going to be a Disney princess?
someone did ask that, actually. I can't remember what the answer was. Someone asked if we get to meet Daisy. I don't know who that is. Is that from Star Wars or something?
Yes.
Anyway, sometimes I wonder if I'm a real programmer. So we're going to be looking at property testing. Just say introduction, I'm not an expert in property testing. I've looked at it a little bit, and including not just FsCheck, but a similar thing, property testing in other languages. So I know a little bit. I'll tell you what I know, and hopefully we'll get through it. You know. So this is. I don't have a strict agenda, but it's along these lines. I'll talk a little bit about the history. I mean, not much, just a quick slide. And then we'll talk a little bit about what property testing actually is. And then we'll look through maybe some code examples. So I've ported to F# an example from the Haskell book, Real World Haskell, which is free on the internet. Actually, you don't need to buy the book. I have a link to the chats that I nicked the example from. And then I've got a couple more examples from a book on FsCheck, which is not free, but it's a little book. I have a copy with me if anyone wants to look at it, or if I've not pizza. So, just a quick look on the history. The starting point for property testing was something called FsCheck, which is a Haskell library, which was written by those two guys somewhere around 1999, 2000, not exactly sure, somewhere around there. Since then it's been ported to a ton of languages. You know the language, there's probably a port of FsCheck to those languages. So FsCheck has FsCheck for Scala, and there's at least 3 different ones for JavaScript. I'm having a bit of a go at writing my own ports to JavaScript, just kind of for the fun of it, but I may actually stick it out there when I'm done. So there's a couple of ways you could look at property testing. One is it's just a way of automatically generating test case data for you. So on the top here we have this is X units, but there's similar stuff in N units. So using attributes, you have a parameterized test function. Here it's just a couple of ints, and it's not a very interesting test, but it's more the structure that we're looking at here. So here we have some explicit sets of test data that we hope are going to sufficiently cover what it is we're testing. So the middle box there shows what an equivalent property test might look like using FsCheck. So, and the bottom version shows what it looks like with some of the ceremony taken out using an extra package called FsCheck.xUnits, which integrates FsCheck into XUnits. I think there's another one for N units. I think there's others for FsCheck and all the stuff sort of Mike's looking at. So there are a few different options for integrating your FsCheck with other unit testing frameworks. So in fact, the one at the bottom is actually looks pretty nice. There's the one in the middle is a bit more fussy. There's a bit more going on, but you can make it as simple as the guy at the bottom there. Yeah. Oh, wait, we didn't look at the other way of looking at it. So the other way of looking at property testing is not just that it randomly generates test case data for you, it encourages you to think about the properties or laws of the thing that you're actually writing, be it an API or a class or some functions. So, what are the sort of invariant laws and properties of the thing you're writing, and what can I assert about the thing I've written? You're trying to set that up as something you want to try and prove, and then FsCheck will then do its damnedest to try and disprove it. It will try and randomly generate data to pass into your function, trying to find a counterexample that disproves the theory that you're postulating. So this example is part of what I'm going to be looking at later in the example from the real world asset book. So we have a quick sort function here, which I'm not actually got the type signature up there, but it takes a list of some type and returns a list of some type with that list being sorted. So a couple of properties here that you might want to test for such a sorting function would be sort of the top idempotent property there says if I sort a list multiple times, it should be the same as just sorting it once. So in this case, we're doing sort of sorts and checking that gives the same result sorting it a single time. Seems like a pretty reasonable property to try and prove. And in the bottom case, we're saying that once we've sorted a list, the first item in that list should be the minimum value of the original list. If that makes sense. It does. So, whether those two ways of looking at it are all that different? Yeah, hi.
Hi, you're right. When you say it tries to find corner cases, does it have strategies to explicitly find corner cases based on code paths and that sort of thing, right?
It's more that it just generates random data.
So over time it will find you corner cases.
Yes,
Yeah.
obviously it's not guaranteed to find you corner cases,
Yeah.
but there's a good chance it will find corner cases that maybe you wouldn't have thought of. I mean, in these trivial examples, maybe it's that's a little. It's probably not quite the case, but if you've got a function with a slightly more complex input, maybe some sort of recursive data structure or something. How many test cases are you going to write explicitly and pass to it? You probably think of a good few, but chances are this will randomly generate some ones that you hadn't thought of.
Yeah,
And
over a few weeks of CI.
and expose some problems and regressions.
I think is it fair assumption to make about that? At least when you're dealing with basic data types, if you give it an int as an input, for example, amongst the 100s it will definitely pick min, max, 0 as its maybe first 3 values or its first whatever. So I think
I think it does kind of try and
when it's
include.
basic data types, it will always pick the edge cases like almost first to begin with.
Yeah.
And then sort of throw in lots of random noise there.
Yeah, pretty much.
So how much you say it generates random data? I mean,
Yeah.
I assume it's not just picking a random thing each time. It generates a set of hundreds or thousands.
So by default, it generates 100. So it'll call each property that you've defined. It will call it 100 times with a different set of random data each time. Obviously, some of those might end up being the same randomly generated value, but generally speaking, 100 different test cases. If it finds a counterexample after 8 tests, it's not going to bother with the other 92. It will hone in on that one and report that as a counterexample. And it will give you all the information about what that random data was that found, that disproved your property, so that you can then go off and try and track that down. Actually, it does get a little bit better than that. It also tries to simplify the counterexample using a process called shrinking, which I'll get onto a little bit later. But that's very useful because it can do half the debugging for you. So, for example, if you've got if your function takes a list of integers, and this is a bit of a trivial example, but if you take a list of integers and one of the test cases, the counterexample that makes your function fail is a list of 17 numbers, which happens to have the number 33 in it repeated, and that's actually what caused the failure. The chances of you looking at that 17 numbers and spotting the repeated 33 going, aha, that's what it is is pretty low. But the shrinking will actually try different versions of that 17 element list. It will try shorter versions until it can get the sort of the smallest, the most simple version of that counterexample that still demonstrates the problem.
Which might be in this case just a list containing 33 twice.
Yes, it may even be simpler than that because it will then also try and shrink the integer. So you'll probably end up with a list of 0, 0. Because there's nothing special about 33 and kind of 0 was not special either, but it's I don't know, like the simplest number if that's a thing.
Have you ever heard of a tool called PEX? C#. I appreciate you're a Scala guy, so maybe not.
PEX, that does ring a bell. I'm sure I heard that
It's
somewhere.
like 2009, a Microsoft research project where they there's a piece of code that will take tests and try and execute every.
That was the thing you were asking earlier about the code paths. Yeah, that's I read that somewhere just literally in the last day or two.
Is this a bit different to that? Is this more about?
I think it is. Yeah.
Just exercising different input, trying to find. Bits
Yeah,
that
that
fail.
sounds kind of a different approach, kind of possibly arguably a cleverer approach, maybe.
Is it a static code analyzer as well, so it
Yeah.
analyzes the code?
Yeah, maybe. I'm pretty sure this doesn't do any of that. It's just randomly generating. It's kind of a
Yeah.
brute force thing almost.
So time is it this guy's advantage?
Yeah. So, I mean, I said 100 by default, but you can do more or less. You can say 10,000 or whatever,
Yeah.
or maybe you have different settings depending
Hex
on.
fails horribly.
Second?
Hex fails horribly.
Oh, just generally. Oh. I've never tried it, but is it still being developed? Or?
It has problems with complex data types.
Ah.
Which is where this is going to win, I think.
Yeah. Actually, this is very good at just generating data for. I mean, it surprised me. Actually, I'll come on to it. I got a code example, which I only found out last night. I was looking at it. It's writing an additional code example, which is kind of similar in structure to one I already had working, and I just couldn't get it working. It was like ignoring. I had a custom generator, so rather than the out-of-box generators for lists and ints and all the rest of it, I had my own little point type, a couple of floats, and. Actually, I don't want to spoil it. I'll come back to that. We'll leave you.
Jack, just before you move
Yeah.
on, it's tangential, but I can't decode those last two lines. So what's the equal right hand?
Yeah.
What's
the point,
that?
actually?
And also, why is it lazy? I don't understand what.
Yeah, no,
optimal-
that is a very, very good question. I wish I'd brought me a free t-shirt. I could have been lucky owner of an oversized t-shirt. Right, that is a very, very good question. So that equals greater is called the implication operator. So what it's saying here, we're about to call list.head. In other words, give me the first item in the list, which is fine if there is an item. Not so good if there's an empty list. So what this is effectively trying to do is filter out randomly generated int lists that happen to be empty lists.
So that's an operator defined by FsCheck.
By FsCheck, you don't have to qualify it. It's got like an auto open thing, so you don't even have to say bring in the funny operators.
Yeah.
Anyway. So the other question you have is about why the lazy. And actually, you don't have to use the lazy. In this case, it would probably work happily without it. But let's say this was some noddy division by 0 type thing. So I have two numbers I want to prove that I want to divide 10 by 2, I get 5. Or something. So what happens if the denominator is 0? So I can stick a little implication operator saying only when the denominator is not 0. But it will try and execute the other bit anyway, unless it's lazy.
Oh, I see.
So the lazy bit is there to say, don't bother trying to execute this until we know we've got the all clear that the data's how we expect it to.
Because it's got to evaluate everything anyway, isn't it? To sort the list. There's no optimization in terms of the list management. It's just because otherwise you get that statement.
Yeah, it's not labeled. I suppose maybe, perhaps that might be a valid argument as well, though. In fact, that's not principally why it's there.
Sure. No,
And in this case, as I say, actually no, yeah, if I went ahead and did list.head with an empty list, it would blow up anyway, so
Yeah.
the lazy is required, I think.
So it's kind of like a short circuit rule.
Yes.
Yeah. So, I mean, there's different ways of going about this. In this particular example, I think there's a way of saying, I want a non-empty list. So instead of just saying int list, there's ways of saying, I want a non-empty int list.
Right. Yeah.
Which sort of pre-filters out those generated data. And you have to be a little bit careful because if you have a really stringent implication check, like I want a list of ints where they're all even, that's going to get a little bit dodgy because it's trying to do 100 tests. I think by default maybe it will try to generate 1,000 sets of data, and if it can't get 100 out of 1,000, it'll say, I give up. So you can get a message saying, I ran 83 tests and they all passed, it was looking good, but I can't get 100 tests that satisfy your crazy constraints within the 1,000 that you've given me. Well, I think you can increase that 1,000.
Does that run the danger if you put constraints in of making the test take longer to run?
Yeah, it's probably that as well.
Time then extrapolating out valid sets of data through the constraints.
Yeah, and so another approach is to not use the built-in int list generator stuff and actually have your own custom generator where you know you're generating data that's going to be within your satisfy your constraints, because then that sidesteps the problem entirely. But it means you have to write custom generators to do it, and we've got plenty of examples of those in the code stuff. So yeah, two different ways of looking at the property testing. I don't know if you think there's much difference there. Is it just generating random data for me, or is it forcing me to think about the properties? It's kind of a bit of each, probably. So, just on the subject of custom generators, there's lots of little tools that you get in FsCheck to help you do exactly that. So out of the box, you get default generators for all the primitive types, so ints, floats, bools, date times, all those sort of things, and lists of those things, and tuples of those things, and all sorts. So you get an awful lot out of the box, and including, as I discovered the thing I was hinting at last night, I had a custom type. I had a custom type that was like a recursive, well, we'll get to the code in a moment, but it's like an expression tree of different types of expressions, so constant values and additions and multiplications of quite an arbitrary complexity. So I was this is a port of one of the examples from the Scala chapbook. They're illustrating how you can write custom generators to generate data of that sort of more complex type. Lo and behold, it was generating it for me without me. It wasn't even hitting my generator. I thought it was hitting my generator and life was good. I was wondering why I kept tweaking things and it didn't seem to make an awful lot of difference. So that was not as random as I thought or something. But, in the end, the thing with XUnit is if you just put printfs, they don't show up. You have to jump through some weird interface thing. I forget the name of it. I test adapts or something like that. So I just got it to throw an exception as soon as it hit that. As soon as it got into the generator of the code, and that exception was never thrown. So maybe it's not actually hitting that part of the code, and it wasn't. So just when you thought you got a handle on it, turns out I was entirely wrong. So if you do need to start generating your own random data because for some reason the built-in data types aren't, you need more control. You need random numbers between 1 and 10, not all possible ints. Then there's a whole load of little, and these are kind of called combinators in the functional world. Kind of combinators. So you have a gen of some type A, and then lots of combinators that allow you to kind of make more complex shapes out of simple pieces. So the very simplest is constant, which I have an example of here. So what we're doing here, he's saying constant 42. So it's kind of not all that random because of the randomness, it will always give us 42. And there are some reasons why you might want to do that. So what I'm doing here is there's another function supplied by FsCheck called sample, if you may want to see some samples of what our random data looks like. Is it the sort of shape that I'm expecting to have the values that are sufficient for my purposes? So here, the second number 5 says I want 5 samples. That's easy enough. The first 5 is a little tricky. It's around something Charlie just hinted at earlier. It kind of starts with simpler random data and generates sort of larger data. What larger means depends on the exact data structure. So maybe a deeper tree, or along the list, or larger numbers. It depends on the data type. So the first 5 here indicates that actually it's going to make absolutely no difference for const 42 because it's always 42. That's the point. But we'll see that number 5 make a bit more difference. Let's look at a couple more examples. So here you can see the output. It's 5 lots of 42, which is kind of what we'd expect. So here we're choosing a random number between 1 and 20 inclusive. So again, that first 5 probably not really having any impact here. The second 5, we want 5 values. Elements. A bit like the last one actually, but the elements here could be anything you want. It's just a list of values. So it could be a list of colours, or a list of vegetables, or whatever you want. And again, probably that first 5 not making any difference here. One of. So, one of takes a list, not of values, but a list of generators. So it's getting a little bit trickier. So we've got 3 kind of buckets of data in terms of those numeric ranges. And it will randomly pick, every time you call this, it will pick one of the buckets and then pick a random value from the buckets. I'm sure it's useful for something. But this one is a bit like the previous one, but instead of equally weighting which bucket it's going to choose, you get to set the weight. So I've done them here so they add up to 100, 20, 30, 50, so they're kind of percentages, but it could equally be 137, or it's done by ratio. So here we've got 10 and the 5, probably not making a difference yet. List of, no. Okay, so I have the first 5 is starting to make a little bit of a difference here. So choose a number between 1 and 10, and then give me a list of those. And we'll notice we're not actually specifying how long that list should be. That's kind of where the first 5 comes in. So you'll see we've got a singleton list, then an empty list, then 3, then 2. So we've got a mixed bag. It's not saying I always want a list of 5. I think it's saying I want a list of up to 5. So we get a sort of mixed bag of lengths. And then there is actually a list of length explicit, in which case that first 5 is going to get ignored again. So here is saying numbers 1 through 10. I want a list of 5. So length 5, but each element is randomly picked from 1 through 10. So you'll see that each of those 5 samples has a length of exactly 5. This is the last one. There are more combinators, but we don't want to get to look too many. So here, again, first, in fact, both 5s here are probably being ignored. We have a set of values, 1, 2, 3, 4, 5, and every sample will be a permutation of those numbers, or is it a combination? Well, it's a permutation, is it? Because there's one of each, I guess.
It's doing all the pipes.
It's an array.
Okay.
That's So
It's an array.
it's generating an array of. No, it's generating a list of arrays.
Yeah.
So I think there's square brackets on their own, bunch and a bunch of things is a list. We've got 2 square brackets with the pipes just inside it. It's an array.
An array is one bracket.
Yeah.
So what we got, a list of
arrays?
arrays?
There's one at the end. It's a list of arrays. So you can see this extra square bracket on the left, extra square bracket on the far right.
Cool. Well, I was lying. There's one more. So you can add a predicate or a filter. So you can say, give me random ints. Oh, actually, I've not defined what gen int is there, but it's basically just there's something called arp. So you can say arp.defaults dot generate, and then in angle brackets your type. So you can say arp.generate int. That's what gen int is. So basically, it's the out of the box int generator.
So if you had your where you were generating, say, random lists, you use that to filter out the empties, for example.
Yes.
Does it do anything clever, or does it generate random number, check if it fulfills predicate, throw away if it doesn't, generate next? So if you were to say where n was greater than max value, would it just sit there spinning its
It probably would
wheels forever?
spin its wheels, but there is a try where I think there's quite a lot of aliases going on in FsCheck. I think part of that is because you can also, as another point I meant to mention, you can also use this from C# or indeed any .NET language, Visual Basic. But maybe, I don't know, I certainly haven't tried that. But I have tried it from C#, works quite nicely. But there's bits of stuff in the source that makes it kind of more C# friendly. So you do end up with a certain amount of, there's like 2 or 3 ways of doing some things. So another name for where is filter. And there's also a try where and a try filter, which returns an option of type, which is, I don't know how it decides how many goes to have before it gives up. I might have to look that one up. But it doesn't look forever. So if you say why it's greater than max int or something ridiculous, then it will give up at some point and just return one. Arbitraries are a bit of a funny animal. So the main thing in FsCheck, apart from the actual mechanics of running a test, kind of at the heart of it is that gen of A, the generator of random values. Arbitrary combines 2 things, the generator of A and a shrinker. So what does a shrinker do? It's the thing I was talking about earlier with the list, the repeated number and stuff. So in that particular example, the tick A would be my list of 17 numbers with its repeat 33, and the result of shrinking it would be a sequence of different versions of that list, generally getting smaller. You have to kind of converge towards that ultimately returning an empty list of possibilities because we've run out. So that's kind of the contract for shrinking. I think the default shrinker takes a tick A and returns just an empty sequence. It's effectively disables shrinking.
Sorry to just jump back a bit. I was just a bit, I don't know if I really understood about the first 5 having an effect. I don't know if you said there was an example where it has a bit.
Yeah, I think the only one I have an example of here is this one. I mean, you can play around with this. I have a playground FSI file, FsX, wherever it is. I shouldn't know really, should I? But I have a playground file where we can experiment with some numbers and see what they all look like. But essentially, it's kind of vague because it depends on the type of value that you're generating.
Yeah.
So if you generate, well, actually, even if you're just generating an int, I think if you had a value of 20, then you may start seeing numbers up to 20 versus the value of 1,000 where you may see values up to 1,000. And strings, I think it probably roughly equates to the string length.
Okay.
But it's not an exact value of always generate me strings of length 10 or whatever. It's generate me some strings up to maybe about 10. So it'll start maybe with empty strings and just work its way up.
Okay.
Because generally, if your property is going to fail, it might fail with a smaller, simpler test case.
Are you trying to find, is it kind of trying to find like the simplest thing that will fail it then?
Ultimately, yeah. So there's two prongs to that. One is this sort of size idea of starting generally small. I'm only using quotes because what small means depends on what the data type is. So it means different things for a list or a tree or but yeah, generally a smaller, simpler case of your type and building up to more complicated, bigger types. And then the other prong is the shrinking mechanism. So if it doesn't fail with a smaller test case initially, it fails on something bigger, it may still be able to whittle that down to something smaller, which is then easy to debug.
So these tests can get like a load of permutations for like any given set of values. But I mean, it isn't just 100 values, it's 100 values plus.
Well, it's 100 specific instances that it happened to generate that day, and obviously next time you run it, you'll get probably 100 different values.
But for a list of say 5 values, you pass it to the shrink, the sequence shrink thing. It sounds like it's going to be effectively 5 factorial things. Yeah, it's going to be testing the way to try and shrink it.
Well, I don't know if it's absolutely rigorous about trying all possibilities.
Yeah.
And certainly as a custom shrink, when you write your own custom shrinkers, you have explicit control over what sort of strategy you're going to use to...
Criticism, it just seems quite...
No, I mean, I don't think it maybe exhaustively tests all shrinking possibilities, because as you say, there'll be an awful lot. But I think it's also why it's a sequence, which is a subtlety that was lost on me when I translated one of the examples from Haskell to F#, which I was going to mention, but actually, when we get to it, if we ever get to it. Well, I lost the train of thought. Yeah, so that, I think, this is where we see F#'s a little vague, but I think with the sequence you can have like lazily evaluated items within the sequence as opposed to a list, which is, a list is this,
Yeah,
and that's
the
that.
sequence can be infinite.
Yeah, so I think, so you could just say, my shrink sequence return value is this lot, get on with it. Or I guess you can kind of lazily evaluate options, and if it needs to evaluate an experiment with more shrinking options, it will sort of hack its way through that list. But it will stop trying to evaluate shrinking options as soon, I think, as it hits one that's... Actually, I don't know exactly how it works on it, 100%. It's refreshing, really, honest, wasn't it? We covered this guy, that was not very interesting. Oh, shrinking. Yeah, I think I was running out of steam with my slides. So, shrinking, what is it? Well, it's a way of simplifying the counterexample, that's the best I can put it. But I did nick these bullet points from somewhere, I can't remember where. It might have been it's from one of the papers. I have some links to some interesting papers that I managed to find. Some of them are linked to from the FsCheck site, some from the quick check documentation. There's a pile of interesting links. I've even read some of them. I think I nicked these bullet points from there. So broadly speaking, if you have some reasonably sophisticated type, not just an int, but something like a more complicated structure, or particularly a recursive one, then these are some things that you should maybe consider if you're writing a custom shrinker. So the first is to shrink individual subterms. Maybe this will make more sense when we actually get some code. Should probably get on with that, in fact. Yeah, we'll come back to that. I'll jump back to this slide when we... You didn't see that, did you? Right, sorry. There's a look at some code, eh? Right, where should we start? Well, this one's quite a nice example. So, we've already seen a little bit of this in one of the slides earlier. So there's our queue sort. Is that quick sort, is it? I guess? Yeah. I just made this simpler earlier. I managed to get rid of 3 lines of code with the partition function. So, I don't suppose we want to particularly dwell on that implementation. It just sorts a list of things. Although, I will just mention that it sorts a list of tick A, so it doesn't care what the things are. But ultimately, the property test will, because you can't generate random values of tick A. It needs to know what type do you want it to generate.
So when you say tick A, do you mean just a generic type?
Yeah, the little signature there. So that's tick A. Is that how you pronounce it? Or
Yeah.
Yeah.
Oh, yeah, I had a question about that. So far we've seen it generating integers. Does it cover all of the simple types?
Yeah.
And
So all the
does it
primitives
do
are there.
other things for strings, or does it just generate strings of gibberish, or does it try? Can you ipsum lorem it, or
I don't think it has Ipsum lorem, but I don't know for sure, and that would be quite a good addition, wouldn't it, actually?
Should maybe build one of like a random chart array
Yeah.
generator, and then we can mark those together and sort of build
Yeah.
them sort of thing.
Funny you say that. It's reducing thing. Stinks. That sort of
Yeah.
But then sort of also what you just said that it can't quick check generic types. So like if you just had a list and you wanted to check that, say a list with one element minus one is the same as an empty list, you would have to tell it, okay, do this but with a list of ints, or do this but with a list of chars or balls or whatever.
Yeah. But it doesn't stop you writing your function in a generic manner. So we have a generic thingy there, and then I have a couple of little helper functions here, which in Haskell you get for free from the Prelude library, standard library type thing. I was reading that this apparently is point free style. Is that something people are familiar with?
Is what's that say?
It's called point free style. Because you'll notice it doesn't take a parameter. Well, it does actually, it just doesn't say it does. Well, actually, no, it doesn't take a parameter. So what it does is it returns a function that takes a parameter.
I just call it partial application.
Yeah, it probably matches the same thing, but there is actually a name for that. I don't know, is it a pattern or a technique? I don't know. It's called point free.
I'll start calling it that for now.
Yeah. I think the point refers to some sort of it's a point in mathematical space as an input or something, but I'm not.
A lot of function languages use points to say it's the end of a function, and then flight creating and stuff like that.
Yeah. I mean, obviously, you could just do X's here. Live coding, and you shouldn't do it. I mean, that will be exactly the same thing, or logically the same thing, but it's just not specifying that. Anyway.
I prefer the point free one.
And the code insight does as well.
Yeah, it does actually. You're right.
Oh, did it? It had a squiggle.
It didn't have a squiggle, but the type signature looks a lot more complicated.
Yeah.
I think if you're in VS 2017 and have the F# power tools turned on, it prefers the point free one. Oh no.
Yeah, so that says tick A list to an A.
And it's got a nice comparison. So it's got a constraint on it as well, I guess.
Yeah.
Yeah.
Presumably that constraint would exist anyway, because it's doing the same thing.
So, a newbie F# question. The lesson operator. How presumably types don't automatically do that. Is that there's some kind of
I think at the top where it says requires comparison, it's
Yeah, the same
okay, that's a
constraint on it.
Alright, cool.
Actually, that's an interesting difference, because that doesn't say, so you wouldn't know.
It's because you've used it later on within, so it's inferred that it's
Oh,
a
yeah.
taking function.
Ah, yeah.
Whereas when you change the signature, it's just assuming it's generic.
Yeah.
Something like
I think the VS power tools, F# power tools prefer you to go for the point free style. I might be misremembering that, but certainly also reading books on it. So I think this is the preferred style. If you don't have to, if you can do it this way, do it this way.
Yeah. Okay, so we've already seen these first two properties because I had them on a slide earlier. And obviously here I am saying it's explicitly an int list. So I could have chosen some other type there. But I have to choose something, otherwise it won't know. It needs some help as to what type it should be generating. So we've seen the minimum with its implication operator thingy there.
Sorry, John, is that true? So if you get rid of that type annotation, will it just throw an error and say I can't run this test? Or will it just default to a generic? Would it just default to an int because it's the simplest thing you can think of?
That's right. So I just say X is.
It's probably okay on this one because it's still inferring int from other uses of it.
Yeah, because it knows from the minimum.
Yeah.
I just wonder if FsCheck would say, hang on a minute.
I think
Maybe should try it on the other.
probably.
Was it
Okay.
referring in or minimum because of what we used? That's slightly circular.
What happens if I do it on this one? X is.
So if you ran that now,
Oh, no, it has got
Is-
this generic list, hasn't it?
is he gonna run all right? Is he gonna work?
Actually,
It's the same as .NET. It's like chest.
didn't like something. It doesn't normally do that.
Create an entrance.
Oh, it's trying to do some reflection.
Yeah.
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 And not create an instance contains generic parameters as true.
What was it trying to create?
So it's
Well, it starts as a dynamic, and then I think it tries to hit constructive as they're constructing a dynamic. It's like,
Yeah, it's trying to use reflection to get a dynamic function. It
So-
contains generic parameters is true.
So it's checking that property saying, oh, can't help you there, mate.
Which I guess kind of works, because how can it generate random values if it doesn't know what the
No, well, exactly. But you know, interesting idea to you know, I didn't actually bother checking to see what happened when I tried it. So there you go. Cool.
But is that kind of saying that it could generate test cases for a completely generic type as long as that generic type didn't have any. I know, wait, sorry. You want me? I can't read. It's like.
yeah, it uses dynamic.
I suppose maybe we can have a test that took a list of don't care and checked that length was something more than 10 or something.
So it'd be a
We
combination
wouldn't really
of
care
generics.
what type of thing was in the list. So you may be able to get away with it in some situations, perhaps.
So you don't have like quite the same as is it like the nothing type in Scala where absolutely everything inherits off it, even like null, even and it's,
I guess you've got objects, haven't you, ultimately?
Yeah.
Just similar sort of
Guards around
thing. Yeah. So actually, let's just run the test. I've not actually done that, so let's just see if they all run. They should do. So I've got some examples of some failures later because they look a bit more interesting, and we can see shrinking happening. Yeah, so they do all work. Good. Right. So I don't know if there's anything particularly more interesting in here. Minimum and max, pretty much the same thing there.
So is that just using the Microsoft test runner thing, or no, XUnit? Is that what you?
Well,
On the command line.
I actually execute the test just using .NET test there. Because I originally created this project using, or Mike created it for me in the pub because I was having a meltdown and I couldn't get anything to work. How did we do it?
We tried everything until something
We
worked.
tried it until something works. Actually, do have
Did you resolve
That-
the command line to create?
did it like that, project creation. So we did .NET new XUnit with language F#, and then slung in a couple of packages.
Yeah, we were using Ironide and Forge, and it looked like those templates hadn't been updated for quite a while, and they just didn't seem to want to work anymore.
Yeah, so we dropped back to, which I kind of prefer to some degree. I mean, to be honest, I don't do an awful lot of F# development because I'm, well, the day job now is Scala, but yeah. But when I've played around with it a bit, I kind of tended to create similar projects as well. So there is a repo of this code, not that it's all that great, but and there's a link to this. I don't know how you share links, but I'll let the organisers maybe worry about that one. But I do have a link to the slides and a link to this little repo, which is the code we've just been looking at. Which
Yeah,
I found
I'll
useful.
put it all together in a pack and stick it in there.
Cool. So yeah, I'm just using that simple XUnit running commands. I don't know, I had a thing to check into and I never got around to it. Around whether, this is not really an FsCheck question, but can you tell this thing to only run that test or this test rather than all of them? I don't know. But it's not really an FsCheck issue as such, but I managed to find out. But there's not that many tests in here, so I just kind of didn't really worry about it too much. Yeah, these are just some more general properties that might exercise the quick sort. I guess this ordered one here is particularly germane to sorting. Just checks that given a random list of ints, when I source it, it's ordered according to that implementation of ordering. Assuming the implementation of ordering is correct, I suppose. But, so anyway, this is another sort of similar example, really, I suppose. So this is actually from a talk that someone had worked with on FsCheck. So it's working out the Euclidean distance between a couple of points, and then there's some properties about that that you can. These are actually listed on the wiki page. These names, triangle inequality, and lots of stuff. So they're fairly simple implementations. Probably the more interesting thing about this example is this business here, and the fact that I have a custom generator here. And the reason I have a custom generator is because if I let FsCheck just generate points, which it can do out of the box, it just does it. Its default implementation of generating floats includes nans and infinities and all sorts of weird things like that, which get in the way a little bit. So there is actually something called normal floats. So this is our default business I was talking about earlier. So all the default implementations of the built-in generators for primitives and such live on r.default. So there's an r.default.float. There's also an r.default.normal float. So normal float takes float and filters out the stuff that it carefully added in. I think if you look in the source code, it is actually explicitly adding a certain quantity of nans and infinities. So it will generate random numbers, including in max and max value, min value, and that sort of thing. But it also sprinkle in deliberately some nans and some infinities using the frequency thing that we looked at briefly earlier. So it explicitly says, for the most part, generate kind of normal numbers, but sprinkle in 1 in every 10 or whatever, drop in a nan or an infinity bomb. But in my case, those, the maths aren't going to fly too well with infinities and nans. So, I mean, maybe you'd want some of those to check that maybe I should be throwing some library-specific exception when that happens, which I'm not. But in this simple case, I just want to ignore those type of values and concentrate on more regular numbers. So to do that, I've had to create my own custom generator for points. So I've called it genPoint, call it what you want. So here, just for convenience, I'm grabbing the generator of normal floats. Normal float brackets actually returns that arbitrary thing that we looked at, which packages a generator and a shrinker together. And here I'm just saying, well, it's the generator I want out of that. So I can generate ints of type that aren't nan and infinity. So, and then here, actually it's kind of interesting. This is a computational expression, which some of you may have looked into. So we're saying, grab me a couple of normal floats and pull them x and y, and then construct a instance of point with x and y set to these values. These float here, that's sort of effectively casting, I suppose, or converting the normal floats, sort of wrapper type, back into a primitive float. It doesn't work without them. It doesn't seem to. So.
What is the bang?
Yeah, that's a good question. Who asked that?
So the problem is that the expression on the right, I'm going to get this all wrong, actually generates monads.
Yay!
You used the
I
word.
thought you said we didn't use
I used a
those.
bad word, sorry. And computational expressions, let bang usually allows you to kind of ignore the fact it's a monad. It's a sort of syntactic sugar to wrap that away from you, and you can just pretend you're dealing with the unwrapped form further on in the expression.
Yeah, so if we hover over this guy, you can actually see that it is a gen of normal float.
Expressions in Scala?
No,
Yeah, okay. I thought you'd done them. But yeah, we've got a for expression in Scala, which is a similar thing of binding a variable to one thing, but it's not helpful if you don't know what for expression is.
Do you do C#?
yeah.
So you probably use, the link expressions, not the ones where you chain all the functions together, but the ones where you do from select. It's very, very similar to that.
Yeah.
So where you'd normally say, in fact, this in C# syntax would say, from X in gen normal floats, from Y in gen normal floats, select point of XY. It's exactly that.
I get that. That doesn't explain what the bang is, though. But I get the bang from different places.
It's the syntax.
Yeah.
Hopefully we're going to have a talk about computation expressions in the future.
Yeah.
Cool.
But
Just to very quickly,
Right?
because you can have a let expression in a linked syntax,
Yes, you can. Okay.
which effectively, which isn't doing anything fancy like what from does, but what it does do, it says, the thing on the right, little expression on the right, maybe it's 1 plus 2, let's thread equal 1 plus 2. So that's basically just like a variable assignment, which is different from what from what from is doing. From is the tricky one that's actually reaching into this funny gen thing and pulling out a raw value. So you can think of gen of float as the value you want trapped in a box, and the let bang just for the only for the duration of this expression. It very briefly lets you have direct access to the float that you want that's trapped in the box. So take the X out of the box, take the Y out of the box, make something out of the box, in this case a point with values X, Y, and what the return does is it shoves it back in the box. So by the time you come out of this expression, in fact you can see here, it's gen of points, is the signature.
Yeah, I get you.
So we made a point, which we had briefly in our hand, we actually had a raw point object, but now we don't anymore, it's back in the gen. I don't know if that helps.
It's a bit of the let bang is a bit of syntactic sugar when it's sort of following that. There's like binds and returns, and it allows you to ignore that. It sort of takes all the boilerplate from having to unwrap it, rewrap it, unwrap it, rewrap it, and hide it away. It makes it quite nice and terse, actually.
Yeah. Okay, so that's our gen of points using the more palatable version of floats. And this bit of stuff here just makes that gen of point available to us as an arbitrary. So what this is doing, r.from gen, says make me a little arbitrary, which you remember has the two fields, has a generator and a shrinker. This says synthesize an arbitrary for me for points, for a gen of points. This is the generator to use, and I'm not specifying a shrinker because there is a r.from gen shrink where you pass both values. But this version from gen doesn't have a shrinker, which means you get the default shrinker, which basically always returns an empty list. So whenever you try and shrink a point, you always get back an empty list of options, which effectively disables shrinking for this type. The other ones have been lazy and not implemented a shrinker.
So is that because we're using XUnit, and XUnit is C# specific, so we kind of created our custom arbitraries so that there's a class to call the attribute?
I think we'd have to do something pretty similar regardless of XUnit. And obviously I'm using some XUnit machinery here to actually run the test, but ultimately, when I'm running the test, I need to tell it that my property, which is all the way down here, so the property here, point to bool, it needs to know how to make points. Well, actually, it knows how to make points. The point is, as it were, I'm trying to have it not use as out-of-the-box point generator and use my generator so I don't get all the nans infinities. So I guess if you weren't using XUnit, the mechanics of exactly how you would do that would be slightly different. There is something called arb.register. So you can say arb.register my type, which has, it will then, I think it uses maybe reflection to go and look for interesting properties that return arbitraries, and it will add those to its stash of known arbitraries. So that when you then run something like this, it will go and rummage around in its list of arbitraries that it knows about. And I guess if you've explicitly registered an arbitrary for points, that will clobber the out-of-the-box one that it will generate. Or maybe it only bothers generating one if you can't find one that's explicitly there. That's probably more like it, although that's suitably vague. But one way or another, it'll either try and generate one using its own generator or get gazumped by one that you've explicitly registered. and the exact explicit how you do it maybe differ depending on which testing framework you're running.
It's like a cross-cutting mocking kind of thing.
Yeah, kind of, I suppose. So the real interest of this example is probably more of the stuff I just talked about, which is custom generator and how you make it available to a test and stuff. It's this kind of line of magic here that ultimately brings it all together. It says, for all the properties in this module, by default, use the arbitraries that you find by sniffing around in custom arbitraries, of which you've only got one, which is the point. But you can then, I don't have an example here, but you can, within that property attributes, you can add some, I think there's an arbitrary within there that can gazump the properties attribute. So there's kind of levels of making these things available. So that's, I don't think there's anything especially super interesting other than that about this example. How are we doing for time? I don't want to use it all up. It's Mike's got it.
It's quarter past 8.
Wow, I only thought I had 10 minutes left. Should we do some more?
Yeah.
Do we need a quick?
Do people want to have a break to go and have a drink? Yes. Drink, stretch legs. Like 5-10 minute break.
On Scholar check to FsCheck. So the book itself isn't free on the web, but the source code for the examples is, so I've got links to those. So this example, we have an expression of 3 different types: so constant value, or addition of 2 expressions, or multiplication of 2 expressions, and function to evaluate a given expression. And then here we have a function that attempts to kind of transform a given expression into something maybe a little bit simpler. Right, this is a bit of a toy example, really, but so here it's saying if we're adding 2 expressions, then replace it by one of those expressions multiplied by 2. And here, if we multiply by noughts, then just replace it with a constant noughts. And then here we have a glaring bug, which commented out so it doesn't cause it to fail yet, which says if you see something being added to 1, then ignore the 1, just use the expression, which is obviously going to fail, give an incorrect result. And for anything else, just return the original expression. So this isn't really a serious example, really, but it demonstrates, or it will demonstrate when I put this back in, a failure, so we can get stuck into that. So, oh yeah, so this is the one where, so we have a custom generator for expressions here. Probably not worth going through all of it, but so the top bit there, using frequency again. So for some proportion of the time, just generate constant values. So it will be a constant. The actual value within the number within the constant will still be random. Actually, not entirely random. I think. Where is it? Where's at the top of the screen? Oh yeah, here, line 32. So actually, so generate constant expressions containing numbers between 0 and 10. And then the rest of the time, generate add expressions or null expressions. And this expression here is just to try and start to reduce the size of the tree that we're building. So this gets back to that size parameter. So when we're looking at sample earlier, and we had 5 and 5, that first 5 is size. So here we're actually using that size. So we're using there's another combinator here called gen.size, which gives you explicit access to the size, which is that integer parameter there. So we know someone on the outside is controlling the sort of arc of what size of expression we're trying to build. starting with smaller values and increasing in size. But this gives us access to, for this particular value I'm generating now, what sort of size do you have in mind? So you can have access to that through this mechanism. You may not care, in which case you wouldn't bother using this gen.size business. But if you do want to respond to the size, then you can use this to get access to it. So some of those and slightly less of these, which means overall it stops the thing that you're generating, particularly in the case of a recursive tree, getting completely bananas and essentially not completing.
So it's just a way of bringing everything down to a manageable size.
Yes, and in fact, the actual size that it does try and build up to, so it kind of starts small and grows bigger, you can control what the upper end of that size actually is. So it has a default value. I can't remember off the top of my head what it is. I think it's maybe 100, or I could be confusing that with the number of tests, or they might be the same. Whichever, there is actually an attribute for it, which you can use when you attribute your properties. You can say maximum number of tests, max test equals 1,000. I think it's max size equals, and you can make it smaller or bigger than it would be by default. So that's so line 35 is our custom generator for expression trees.
On line 41 and
41.
46, you've got an and rather
Yeah.
than a let.
Yeah, because the gen.frequency is forward referring to gen, particularly, well, gen cons was above, that's kind of the simple case, but gen add and gen mul down here want to refer to gen expression, which means they're kind of cyclic. So you have to do this let recursive expression equals this and this and this. So with the ands sort of gluing these things together, without the ands, it wouldn't let you do it. Because for the gen expression, it goes, I don't know what gen mul is. And gen mul would say, I don't know what gen expression is. And this says, well, I'm just going to deal with you guys all together so you know about each other. That's sufficiently hand-wavy. But yeah, it's basically that. And if you don't put this on, it shouts about something. So no 140 is the way to go.
That was even more hand wavy.
Yeah. No, it does actually say something about if you're generating recursive functions that are kind of co-recursive, then I'd let you get away with it. But you're kind of doing something, you're not doing functions, you're doing something else. And I'm going to warn about it, but you can shut me up with this, and that's about as much as I know about it.
So what's the rec keyword doing?
That's recursive, so without that, it definitely wouldn't work. In the same way that when you declare any recursive function in F#, you have to tell it it's recursive.
Oh, is that just like a compile prompt to say,
Yeah.
tell recursion, go
A
back.
function can't actually see itself. It's
Okay.
think about it unless you mark it as recursive.
But that's not
Probably more
self-recursive.
technical reasoning.
Recursive through GenAdd, which then calls back to itself. So that's probably what you're talking about before. Right, I'm kind of catching up gradually.
Okay, you can explain it to me again, back up folks. I don't know what I'm talking about either, but yeah, certainly with the recursive function, you have to drop in the rec key, whether it won't let you do it.
It's a good point. It's a good point though. If you take it, I must admit, I'm confused about that as well. If you take out the rec, does it complain?
Yeah,
I think it
this will complain.
Yeah,
Well,
lots of yeah. What does it tell us?
It's because in fact through my others.
Sure. Yeah. No, I'm just because if you do that with types, it doesn't matter. You just and types. They don't have to be recursive.
Yeah,
Like
but it's
top
stackable block, whereas this is probably using tail recursion optimization, which .NET doesn't see by default. So I think it's a compiler prompt to say, hey, this is recursive, and this is involved, and this is involved. So you've got to rewrite it internally as a big form of reflection.
Yeah, I mean, this is weird because it's not actually generating. We're not actually declaring, creating a function here. We're just creating a data type, which is gen of expression. So it's a recursive data structures rather than a recursive function, I think.
Is it because you are using the computational expressions there, so there is some functional callback?
Well, it's definitely something to do with. I got gen add there, which is referring to this gen add here, which
Yeah.
here you won't have seen it yet, and then this calls back to gen expression, which is what we're declaring up here.
Yeah.
So yeah, they kind of depend on each other in the sort of cycle, and so the combination of rec and ands is how you would how you overcome that. But yeah, it's something to do with it not being functions but data types that you get that warning.
So is it kind of fair to like almost summarise? I guess rec and and are both artifacts of the fact that FsCheck doesn't allow you to use things until they're defined, like be it file order,
I guess so.
be it type order. And although I guess like the keyword for the function has kind of been named before it's used in the function, but you've not actually finished defining the function whilst you're still trying to use the same label that's used to define the function, if that makes sense. So it's kind of an extension of that.
Yeah, you can use the and outside of the rec stuff when you do have a kind of cyclic relationship between functions or such things. So it isn't just in this instance, but it's obviously exactly into this situation. I think the rec one is also interesting because I don't know if it's doing it yet, but it calls in and flags it up for tail optimization. I don't think in earlier FSharp it did use the .NET internal stuff.
I don't know.
I'm guessing other languages work that out. But like there must be examples of languages that work that out without explicitly having to be told.
C# will, if it can, if you're doing 64 bits, but not if you're doing 32 bits. Just a minor implementation yourself that no one's aware of.
Is it in Scala that you have to annotate it with that tail rec?
I don't think you have to, but if you do, it says, I don't know if it's a warning or an error, but you can get it to tell you, you're trying to make this tail recursive, but you've done it wrong.
It's not going to be able to.
And I can't do it tail recursively because you're using something after the call. So, and I don't know another language that has the same feature where you can say, I want this to be tail recursive, I want you to tell me, I want you to make an error out of this if it's not so. So that's pretty cool about Scala. So anyway, that's the custom generator, and here we have a custom shrinker, which we touched on earlier, particularly for a slightly more complicated type here. Using that funny function syntax, I guess this kind of makes it point free again, doesn't it?
Yeah.
You don't see the arguments, but essentially here, there's an argument to the shrink expression, which is an expression that we want to shrink, presumably because we found a counterexample to some property and we want to try and simplify it to something smaller. So here we just have a pattern match against our three different expression types, const, add, and null. So if we see const, which has a number in it, we call arb.shrink of the number. So that's explicitly shrinking the number. So if the number's 42, it might try 21 and 20 and naught or something. Whether it tries all the numbers down to naught, I don't know, to be honest. I suspect it probably doesn't, because obviously there could be a lot of cases there. So this is basically saying shrink the number, which will return itself a sequence of shrunken shrank numbers, which we then stick back in const, so we map them back through the const constructor. So we've taken one const and made many consts out of it.
Sounds sort of like the opposite of shrink. It's more like grow. Well, we've got one. I want you to shrink it to many of them.
Yes, well, it does sound a bit like that. Well, it is that, but but each of those items that you're returning should be, in some sense, smaller than the one you started with.
Gotcha.
So we might have had const of 42, but the const that we generate, the list of other alternatives, should be smaller. In this case, presumably smaller
Sort of
numbers.
shrinking the problem space.
Yeah. And you're always trying to make it smaller. You have to start converging, otherwise you'll never complete.
And ARB.shrink is what.
Take it?
And ARB.shrink is like arbitrary.shrink is what would reduce the value of 42 to say 41, right?
Yeah. So what this will essentially say, look, here's a number. List of arb. Rummage around in your list of registered types and find a shrinker for this number, and shrink it and return to me the sequence of alternatives that you come up with, which is possibly empty, in case we didn't have a shrinker for numbers for some reason.
Yep.
So and these add and null cases are almost identical. So given that we've got an addition of two expressions, we're going to try a bunch of things. So the first thing we're going to do is we're going to try each of those expressions individually. So what we've done is we've taken a more complex term like add E1, E2, and we're going to replace it with the slightly simpler option of just E1 on its own and just E2 on its own. And you'll notice that we do that before we do these, because these are definitely going to be much smaller than our original expression. So it's worth having a try at those smaller ones, because if that works, then we don't need to even bother trying these slightly more complicated variants. So this is deliberate that you would try smaller, vastly simplified versions of the thing before trying more complicated versions of the thing. So, but anyway, so the more complicated versions are, so this is effectively recursively shrinking our E1, because that's also an expression. So we'll take the smaller E1 within our overall add and shrink that down. And similarly for E2, and with these shrunk expressions, we'll kind of we'll manufacture another add, which is slightly simpler than the original add. So it's, again, always going towards something slightly smaller.
So could we do a kind of a combination of a shrink E1 and E2 to get all the kind of combinations?
Yeah, I mean, you can stick in it, 'cause this is your custom shrinker, so you've got total control over what you put in here and what things you bother trying and what things you don't bother trying. And you can be as sophisticated as you like, try as many things as you like.
Are you thinking using that outside of the FsCheck bit?
No, so where we've got the shrink on the E1, we always have the same E2, and likewise on E2. So we might want to vary both at the same time.
Yeah, you could certainly do that. I mean, this, to be honest, I've just copied this verbatim whilst transfiling whatever the expression is from Haskell to Scala to F#. But yes, you could be as exotic as you want here about the things that you try.
Actually, you could probably use this comprehension to combine those two.
Yes. Oh, and the other thing here is, I've touched on it briefly, is that we're returning a sequence, but you'll notice I'm not doing anything lazily here. So I'm actually up front calculating all the possibilities that might apply to the shrinking expression E at the top level here. The E that's not there because it's 0.3, but shit, what was I saying?
But you are doing a sequence map over that trunk stuff there, which will be lazy.
Also, isn't the caller calling it lazy though?
Oh no, because when we do the concat, that will.
Oh yeah, true. Okay.
Yeah. So really,
it's a sequence concat, so it will still be evaluating it lazily.
Good point.
so it is lazy.
It is lazy.
Oh, cool, awesome.
I was going to ask you a question, which was the lazy before. Is that not what's calling this in the first place anyway?
The lazy we had before was around the implication operator, I think,
Okay.
which was
You're right. Yeah.
kind of a different thing, really. But
Yes.
yeah, so maybe this isn't as bad as I thought. Then there's some laziness. Maybe you can make it.
So
more
our
lazy.
shrinky 1 and our shrinky 2 will be calculated at the point this line is evaluated. However, then the mapping of it to the further adds, that will be done lazily.
So does that mean if one of those comes up, it'll try those before it'll even bother evaluating
so-
that?
yeah.
Okay, cool.
So it will have done. So if you get a problem right in the very first one, sequence E1 or E2, it will not have even done the arbitrary shrink 1 or shrink 2s because it's a sequence concat, so it's a lazily evaluated sequence.
Cool.
I think maybe. I
Sounds
hope.
about right.
So
I'm not certain anymore.
So we've seen our generic, we've seen our custom generator, and we've seen our custom shrinker, and then this is the bit that ties them both together. So we do our from gen shrink. We give both bits. So we now have a complete shrinker on one of these again. This is the thing I tried earlier that I assumed was working because it looked like it was working, but when I dropped an explicit exception raise in here, it didn't go off, which I would have expected it to. So in fact, I didn't have this is what's making it work now. But before I had that, I had this, and I just commented it out, and the thing carried on working. So that, well, something else must be generating these things. It's not me. I only figured that out last night, so I'm glad I looked at it again. And this is really just the sort of thing we had before. That's the bit of attribute glue that sort of sticks it all together. And then a property here. So here we're just saying prop rewrite of expression, generate me a random expression, rewrite it using the function we saw above, and then check that's evaluating the reduced expression and the original expression should be the same thing. And here we have this is a property label. So you won't see that unless it's a problem, but if there is a problem, it will spit the string out and it will say I've rewritten the original expression to RX, which will print out as a sort of string representation. So you'll actually see what it was rewritten to. Anyway, I'll stop waffling and actually run the thing. So we saw it run earlier, everything worked, so that's not really interesting. So I'll put the problem back in, which is this guy. So if we run that again, should see an error.
5 minutes warning.
Okay, I'm getting thirsty anyway.
Is there, it's just a general F-sharp question, sprintf, is there a printf function?
Yeah.
Does sprintf just evaluate from the string or?
So printf is formatted print to standard out, and sprintf is formatted print to string.
Okay.
But I think it
So
does.
it's a string rather than print to standard out. Right, okay.
And I think it does type checking, does it?
Yes.
So if you say
So
print out %d and give it
you put in
the bool
percentage a, which is anything.
yeah.
If you put in percentage d, yes, it would be an integer because d means integer,
Yeah.
obviously.
Is printf implemented with type providers? I think it's just built into the compiler. But the other part of that is it needs to be a string literal in the string format. It can't be a variable. It has to be something you can evaluate from time to time.
Anyway, time's a wasting.
I'm trying to find it. It's a bit of a bugger. It will take a while to generate a more interesting sort of failure case. We're getting failures, but they're not very interesting. That's a little bit better. So what it generated was this expression, which is it's a 4D tree or something, and you can see here I ran 98 tests, so it nearly got away with it. 98 tests, and then I found this is the original counter example. It's then applied 2 shrinks to it, which you can see here. This is our rewritten, that's the label I was talking about. So the rewritten expression looked like const 0. And you can see here, it's basically shrunk that original down to just that simple test case here. And if you remember what the problem was that caused that to happen, it was whenever you see an add const 1, and if you look here, so we have an add const 1 with something on the right. The thing on the right is irrelevant. It's this const 1 here that's triggered the problem. You can see here that from a reasonably complicated original random expression, it's pretty much nailed what the problem is. So if I was having to debug this expression, I'd have to figure out which part of this expression caused it to go wrong. Whereas if I look at this, I think I'm going to find the problem a lot sooner. So that's pretty cool, actually. To be honest, if that's the last couple of minutes, we'll probably just leave it there, really. Because I'm not going to get to a monad slide. Alright, I'll just very quickly, not the monad slide, I was going to work up for it. Just about half an hour. Just a quick one. So one combinator I didn't mention is map. Which is this one just here. So we're taking the constant value 42 and we're mapping it through a string, basically cast it as a string or convert it to a string. And if you look at these other examples for sequence list array, they all have a similar map operation, which you've probably used. And it's, it's absolutely identical. The only thing that's different here, really, is how I got the value into the list. So list singleton, sequence singleton, the gen constant. But the bit on the right is map it through string. The only thing that's different is kind of the data type, really. So,
a function or a type? Sorry.
is there a
string function or a type there?
I think that's a function that
It's like two string.
Yeah. Okay.
I think it's the constructor of the string type, which we're.
And that's polymorphic, so it can do a bit.
Yeah.
So what we're saying here is that all these things are something that's actually called a functor, which basically means it's something you can map over. So another word for it might be mappable. But the mathsy types, so I prefer calling them functors. So I was going to sort of move on with these guys, but that's probably a little bit horrific. So we might leave that for another day, or down the pub, even better. Pint 2. Yeah, I mean, we could do part 2, a little later when I've dug into some of the more esoteric parts of this, because we kind of, to some degree, only kind of scratched the surface. No, we'll put that one away. So, are we looking at beer?
Yeah.
Oh, sorry, questions? Any quick questions, or should we do that down the pub?
I was going to go, so I did have a question, which is just,
Sure.
if I may,
Go for it.
which is just, so yeah, you're never going to write lists, right? So and lists have quite well-defined properties. Where do you find yourself using it? Because I can't think off the top of my head of something that I would write that I would think has these properties that I'd need to test.
Yeah, it's a good point. Actually, I think the hard part of some of this is actually looking at your code and trying to think of it in terms of properties or invariants. I suppose is another way of it's a similar sort of idea. Yeah, that's not easy. Some things lend themselves to it quite well. Anything that involves a round trip, so if you're encoding and decoding or serializing, deserializing, that's a really good fit for this because you can randomly generate stuff and check that when you've encoded it and then decoded it, you get back what you started with. So that's a really obvious and good example. Beyond that, yeah, that is kind of a hard bit, is trying to think of good properties for your stuff.
It's something that would be really useful to us back at a certain place we worked before, where there was a very long-running bug in a bit of an e-commerce kind of solution, which we knew was there. We could see errors turning up in the logs over the course of a year, but we could never catch it in the wild, and we never ever had enough information to nail it down. So having just set a test which would have been able to generate lots of stuff, and then do our shrink when it finally did hit, because there's obviously thousands of things went through this a day, and then once in a blue moon it would error, and we could never get to the bottom of it. Something like this would have been great if it could have just at some point caught it, shrunk it down, and told us this is what that situation is.
Yeah,
Would have been brilliant.
I saw a good. I was watching a video once. Someone talking about property testing. I forget which library it was, but it was the same sort of thing. And they're talking about. She had a slide that said "Beyonce not found," and it's because their website was had a search capability, and someone had searched for a Beyonce with an accent of E, and it came up with Beyonce not found because it didn't find because of the accented characters. It hadn't found a match. So anyway, the moral of the story was I think they started taking production search data and making that available as part of their random, instead of completely random generated stuff, they actually used maybe sanitized in some way production data and used that as not as our random stuff but as actual use cases, and made sure that they could cope with it. So that was quite a nice little example.
Yeah, because I was thinking back when you had the bit where you could use the different frequencies, it reminded me a little bit of using Gatling.
Yeah.
And where you could start weighting the speed with which it produces these user journeys.
Oh, the ramps.
So run them in parallel, and you can scale different types to happen at different speeds. And I was thinking, yes, so you can start getting into modelling the frequencies that you'd see in the real world there as well, for how likely they are to come together.
So there's a couple of examples, things at the bottom here which are an interesting read. I think this one, yeah, they didn't give an awful lot of detail, but we're talking about using property testing in sort of really non-deterministic systems. That's kind of find a way around that. It's an interesting. I'm not going to do justice to it, but yeah, you get these links. It's worth a quick read actually. I think it doesn't take long just to whip through it, like 15 minutes or something. Oh, and this is for anyone who maybe doesn't want to start using this stuff in F#. This repo here is I ported the Scala check examples, the stuff where just some of the things we're looking at and more, to FsCheck, but from C#. So that might be worth a quick look.
Would it be possible for you to put the link to your slides in the comments for the meetup if people want to?
Sure. Yeah.
Please.
And then that's got a link back to this repo, so it's all linking to itself.
Recursive, I like it.
If there aren't any more questions, thank you very much. Right. We did have one final thing